Welcome everybody to another one of James's videos. Today we are going to deal with another type of question solving 2D triangles using your rules, your sine rule, area rule, and cos rule. And let's begin. So if you've been following the other videos, we're obviously moving up the ranks going from easy, medium to hard. I'd say that these are pretty medium level questions, but this is how we would approach it. Now you can also see here in this question, we've now been introduced to, there's a little bit of circles involved. So Euclidean geometry, circle geometry, knowing your theorems. You can see when you start going up into the higher graders, grade 11, grade 12, they're going to start mixing these sections up, guys. So we need to know a general idea of all sections to be able to adapt and utilize those tools in every single section of math. So it's very important. So what we're going to look at here, in the diagram, BC equals 4 mils, BD equals 7 mils, DBC equals 80 degrees, and ACD equals 50 degrees. ABCD is a cyclic. Quadrilateral most probably is what they were supposed to say there, but ABCD is cyclic, meaning that quadrilateral is in a circle. So your circle theorems are in play. Determine correct to 2 decimal places the length 6.1 of DC. Okay, so first one, DC. So what we're going to look at first, and this is something that you're going to have to obviously do a lot of examples for before you can see it straight away. So we're trying to solve for DC. Now, what part of what triangle is DC a part of? So DC is a part of a few two triangles that I can see. I'm going to highlight the first one in red. So looking at that triangle, my mindset is I don't have enough information to be able to solve for DC. Remember, your rules are all scenario based. So do we have AC? Do we have DC? No, we don't. Do we have AD? We do have the angle there, but do we have any other angle? So we clearly don't have enough information for the sine rule here, guys. And we also don't have a V shape or all the sides to be able to use cos rule or area rule. So that triangle is actually going to prove a little bit useless to me. But what if we try this triangle? So what if we try this triangle, D, C, and B? So if we look at D, C, and B, we've got a bit of information here because they said in the question that BD is 7 mils. And it looks a little bit confusing, but we need to read our question. That whole length is 7 millimeters, okay? Not just from here to here, okay? Like everyone would have seen. So what we're going to do now, and we've got CB as well, do you agree? And then we've got 80. So don't we have something called looking like the V shape there? So isn't that the V shape, the cos scenario, side angle side? I think it is. So if we say DC squared equals 7 squared plus 4 squared minus 2 times 7 times 4 cos of 80, and we put that into our calculator, let's have a look what we get. 7 squared plus 4 squared minus 2 times 7 times 4 cos of 80, and that's going to give me 55, 27 reoccurring. But we don't want DC squared, everybody. We want DC. So what are we going to do? We're going to square root. We're going to square root, and that is going to give me 7,43 millimeters. Okay, 7,43 millimeters. Fantastic. Okay, cool. Now, what are we going to look at next? We're now looking at the area of BCD. Okay, well, that's also the V shape, isn't it? So we already got the scenario going, guys. So we can say area equals a half 7 times 4 times sine of 80. And we can put that into our calculator. And if we put that into our calculator, we're going to get 13,79 millimeters squared. Okay, great. Then what's the next question? 6.3, the size of ABC. Okay, so the size of ABC. Now remember I told you that the circle theorems are in play here. So if it's cyclic, there's 3 theorems that take part in this. The one that is the most common is the butterfly. People call it the butterfly or the bow tie. So surely doesn't that mean because it's cyclic that that angle is equal to that angle? So can I not let this angle equal 50 as well because of angles in same segment? Yes, I can. So what I'm going to state here is I'm going to state for 6.3, I'm going to state that angle ABD equals 50, angles same segment. Okay, and therefore angle ABC, which is what they asked me for, is going to equal 130 degrees. They're not too strict on rules, or sorry, of reasons in this section, because it isn't actually the Euclidean section, it's more trig. So if you can get to the answer, fantastic. But I always say cover all your alleys and make sure that you just put in everything. Always writing a story when it comes to paper 2. Okay, always map out what you've done. 6.4, the length of AD. Now AD is this over here. So the triangle that I'm going to use now, and according to all the sides that I do have, I know that, do you agree with me, we have another, and I'm going to do it in another color, I'm going to do it in red, but do you agree with me that this is also, no, we've already done that one. This over here is also a bow tie. So surely this is 80 degrees. So that's, I can state that. So DAC equals 80 degrees, angles same segment. Therefore, now we can use sine rule, because if we're looking at this triangle, we have enough information. We've got an angle, we're looking for the side. We've got an angle, and we've got the side. So we can use sine rule here, guys. So we can say AD over sine of 50 equals 7,43 over sine of 80. Therefore, AD is going to equal 7,43 sine of 50 all over sine of 80. We can put that straight into our calculator, and that's going to give me 5,78. Okay, everyone understand? Everyone happy? Cool. What we also worked out before was DC, so that's fine. We used that. And then we had that. Awesome. Hope you enjoyed that video. That was another type of example using trig rules to solve for 2D triangles, and then a little bit of a curveball with having some circle geometry in it as well. Hope you enjoyed that video, guys. If you did, please click the subscribe button below, and all notes on trigonometry and trig rules will be found in the James book, which is for sale. So if you are interested, please let us know, and we'll get in comms with you. Awesome. Have a good one, and look forward to seeing you guys in the next video.